Electrochemistry assignment 2 with your Lakshma Reddy sir. Arrhenius theory. Which of the following is 100% ionized at any dilution? Very simple logic. It must be a strong electrolyte. It is weak. It is weak. This is weak. So your answer is 100% Psi sodium chloride. Which of the following conducts more electricity? Again, it should be stronger. When you compare with phosphorus acid, nitric acid, boric acid, sulfuric acid is stronger acid. So obviously more electricity. जिसके पास ज़्यादा दम है उसके पास more electricity होता है यार. The degree of dissociation of an electrolyte in aqueous solution depends on temperature. Psi A. Concentration of the electrolyte 100% true. Nature of the electrolyte. Psi A. Stronger, weak, temperature, concentration, all these. What happens at infinite dilution in a given solution? The degree of dissociation is unity for weak electrolytes. Infinite dilution, yes, everything is done. That means all ions are almost out. So this is right statement. The electrolytes 100% ionized. Right statement. All inter-ionic attractions disappear. Then only they go away. So all these are true. At infinite dilution, the degree of dissociation for sucrose in aqueous solution is, sucrose is a covalent compound. Okay, so there is no dissociation. It is 0. Electrolysis. This is one very, very, very good one. Choose the correct statement regarding the electrolytic cell. See, electrolytic cell, there will be cathode and anode. At cathode, reduction takes place. At anode, oxidation takes place. Oxidation reaction takes place at anode is right statement. Remaining wrong. अगर आपको टाइम है तो पास मार के देख लो यार. Pause and check. The following are some statements about electrolytic cell. So here answer given, the correct combination is only C. So check करते. Reduction takes place at cathode is right. Cathode is negative electrode. Electrons flow from cathode to anode, no anode to anode, anode to cathode, sorry. In this cell, chemical energy is converted into electrical energy. No electrical energy is converted to chemical energy. So only C. Only C. Question number 20. The reaction taking place at anode and cathode are at anode oxidation and at cathode reduction. सही question है. Cations go to cathode, anions go to anode, cations undergo reduction, anions undergo oxidation. The electrode through which the electrodes and electrons enter the electrolytic solution is cathode, because cations, they gain electrons. For that electrons, cathode is providing electrons. For that purpose, cathode is providing electrons, right? As electrolysis is in progress, if the cathode plate is removed, then what happens? The ions move at random because there is no reaction taking place. Cathode is mandatory, anode is also mandatory. In the electrolytic cell, flow of electrons is from anode to cathode through external circuit. And from the cathode, electrons are entering into the electrolyte towards the cations. In the electrolysis of dilute H2SO4, what is liberated at anode in the presence of inert electrodes, that is platinum, you can take. H2SO4 gives you hydrogen gas at cathode, oxygen gas at anode. He's asking anode, anode means oxygen, cathode is hydrogen. Which process occurs in the electrolysis of aqueous solution of nickel chloride at nickel? Nickel is there, you see. Okay, that means this is an active electrode. When it is active electrode, at cathode, nickel will be converted into nickel plus 2 to nickel is at cathode. And the reaction is asking at anode. Anode, nickel will be converted to nickel plus 2. It is the case of active electrodes. So this is right. Molten CuCl2 is electrolyzed using platinum electrode. The reaction occurring at anode is anode. Chlorine is there, na? Chlorine is going out. Cathode Cu plus electron use. This is at cathode. Then coming to the 27th one, during the electrolysis reduction of alumina, the reaction at cathode is obviously aluminum takes electrons and becomes aluminum. This is at cathode. Cations go to cathode. When an aqueous solution of copper sulfate is electrolyzed using copper, again copper. Copper with copper means this is active electrode. When active electrodes are there, at cathode copper, at anode copper plus 2. We'll see the question now. The reaction at anode, same. Copper is turning into copper plus 2. One very interesting question it is. Which of the following reaction is possible at anode? At anode, generally anode oxidation takes place. See here, this is reduction. This is reduction. Oxygen 0 to -2 reduction. Fluorine 0 to minus is reduction. But chromium +3 to +6 is oxidation. At anode, oxidation takes place. सही है ना? Yes. Aqueous solution of copper sulfate is electrolyzed using inert electrodes till the blue colored solution becomes colorless. The colorless solution formed is what is actually happening here? Copper sulfate and sulfuric acid, correct? Sorry, not sulfuric acid. We are using water. Sorry for this. It gives you the ions of copper +2 and sulfate. This gives you ions of H plus and OH minus. Copper is converted to copper. At cathode, this is converted to OH. OH minus is giving you O2. Remaining is H plus and SO4 minus 2. These will be converted to H2SO4. One very interesting question. 31st question, you see, after the electrolysis of aqueous solution of NaCl using platinum electrodes, the pH of the solution increases. Why? NaCl plus water gives you NaOH, hydrogen gas at cathode, chlorine gas at anode, correct? This is at cath, this is at an. So this is formed in the solution. Sodium hydroxide is the base. When it is formed in the solution, the pH automatically increases, right? During the electrolysis of aqueous solution of the following, molarity of the solution increases without changing the chemical composition. See, here H2SO4, hydrogen is going to be out, sulfate is not going, O2 is going to be out. So H2SO4 remains as it is because from water hydrogen is coming and oxygen is coming. So the concentration is not going to change in case of H2SO4. If you take copper sulfate, copper is going to be deposited. If you take HCl, chlorine is going to be liberated. And if you are taking NaCl again, chlorine is going to be out. So no change is in case of H2SO4. Aqueous NaCl solution is electrolyzed using platinum electrodes. What is the product formed at cathode? Same, aqueous NaCl plus water, NaOH in the solution, hydrogen at cathode, chlorine at anode. Hydrogen at cathode. At anode, in the electrolysis of fused sodium chloride, Cl minus is oxidized. Na plus is reduced, this is at cathode. Na plus is reduced at cathode. And Cl minus is, anions will go to anode, simple logic. In electrolysis of sodium chloride, when platinum electrode is taken, then hydrogen gas is liberated at cathode, while with mercury cathode it forms sodium amalgam. This is because very, very, very interesting. Na? Okay, now sodium ions and H plus ions, we are using platinum electrodes, hydrogen is going out. But when you are using mercury, sodium plus is going to mercury and forming sodium amalgam. This is all because more voltage is required to reduce H plus at Hg than at Pt. Okay, this is one interesting reason. Mercury cathode process, class 11, sodium hydroxide preparation. I think you remember. Hydrogen gas always evolved only at cathode during electrolysis. No, not required. If you take sodium hydride, hydrogen gas is coming at anode also. H plus ions undergo reduction by gaining electrons. So, reason is true, but R is false because in hydrates it is possible at anode also. So, A is wrong, R is right. Which of the following ions is discharged at the cathode when an aqueous solution of sodium hydroxide is electrolyzed? Aqueous solution of sodium hydroxide, NaOH plus water. So at cathode you will be getting hydrogen gas, at anode you will be getting oxygen gas. At cathode, at anode, cathode hydrogen gas, at anode oxygen gas. During electrolysis of fused NaOH when you are taking Na will be Na plus ions will be converted to sodium, no doubt in that one. And OH minus will be there. OH minus will be giving you oxygen at anode. Aqueous solution of AgNO3 is electrolyzed using inert electrodes. Fine, very good. At the end of electrolysis, silver nitrate is there. No? Silver nitrate means silver is going to deposit at cathode. When nitrate is there, nitrate, it is not going, it is giving you oxygen at anode. So C options. Aqueous solution we are saying. Aqueous solution when you are seeing pH of the solution is going to decrease because OH minus is going to be consuming here. Oxygen is coming means the OH minus ions are going to be consumed. So base concentration decreases. So H plus concentration increases. That means pH is going to be decreasing. One very, very, very interesting question. Don't confuse. NO3 minus ions are not going to the anode. OH minus ions are going. OH minus ions are coming actually from water, for example. H plus and OH minus. OH minus discharged. So H plus remained. That means concentration of the acid is increasing. When concentration of acid increases, pH will come down. At cathode, the electrolysis of aqueous Na2SO4 gives. When you are using aqueous, you won't get nitrogen. You will be sodium. You will be getting their hydrogen better. Okay, aqueous Na2SO4 means you will be getting hydrogen. If you take molten sodium sulfate, definitely sodium, right? Now it is hydrogen. Coming to 41st question. An aqueous solution containing, yes, 1 mole per liter of each copper nitrate, silver nitrate, mercuric nitrate, magnesium nitrate is being electrolyzed. Aqueous solutions using inert electrodes. The values of standard electrode potentials, reduction potential in volts are Ag, mercury, copper, magnesium, all are given. Fine. Write the sequence of deposition of metals on cathode will be. This question is not of this category. This will be after electrochemical series, but we can see. The minimum potential is required for what? Maximum potential is required for what? This you need to remember. Okay. See, all aqueous solutions we are using, in that highest positive value is given for plus 8.0. So that is silver. Silver is first. Then mercury plus 0.79. Next mercury. Then copper. We are not taking here magnesium because aqueous solution won't give magnesium. Only positive values will be coming. Magnesium cannot be deposited. If your option contains magnesium, that is wrong option. Got it? Magnesium not deposited when you are using aqueous solution. When you are using aqueous solution, magnesium is not deposited, not deposited, not deposited. चलो, इस सेशन के लिए लास्ट क्वेश्चन है द इलेक्ट्रोलिसिस ऑफ एन एक्वस सॉल्यूशन ऑफ KNO3 between platinum electrode gives KNO3 aqueous solution beta, or it will be giving you hydrogen, it will be giving you oxygen. Both are coming actually from water, not from KNO3. Hydrogen at cathode and oxygen at anode. Thank you. This is your Lakshma Reddy.